Okay, so now you know what NumPy arrays are and how we can create them. In this video and also in the following videos, we will talk about what we can do with these NumPy arrays. And we're starting off with something very essential, which is accessing the array elements. And so let's first import NumPy. And then using the aRange function and also the reshape function, we first create an array with 27 elements, and then we reshape that array into an array with 3 dimensions. So 3 dimensions because we have 3 entries here, and then each of the dimensions, so this dimension, this, and this dimension, they will all have 3 elements. So that's why the 3 is here. So again, as a short recap, in our first dimension we have element 1, 2, and 3. And then in the second dimension, we have here element 1, 2, and 3. And also in here, 1, 2, 3. And then in the third and last dimension, we're at the deepest level, where we again have elements 1, 2, and 3. And to now index or access an element of this 3-dimensional array, we have to specify which element we want of the respective dimensions. And so in here we have an example for an n-dimensional array, and we put the squared brackets behind our array, and then separated by a comma, we put the indices for the different dimensions. And so again, these indices then tell us which element of the respective dimension we are interested in. So let's make an example. In here we have our array A, we have the square brackets, and then first step we have 2. And so then in the first dimension, which goes 1 element, 2 elements, 3 elements, we take the third element because indexing starts at 0. So index 2 refers then to the third element here. And we can actually showcase this. So if we just pass the index 2 and run this, then we will get the third element of this array here, which refers to this part here, which is again also an array, as we can see here. And this array here might look a little bit awkward, but we can imagine that these are 2D slices that we would stack together, so maybe behind each other or in front of each other, to kind of create a 3-dimensional cube. So this could be the slice in front, then this in the middle, and then this slice at the back. And so then when we take one slice from this 3-dimensional cube, we get something with 2 dimensions. Next step, we have the index 0. So A, square brackets, 2, and then 0. Which is, by the way, the same as if we would close the square brackets here and then put the 0 separately in another pair of square brackets. And so now we're interested in the first element. So of this 2D array here, we take the first element, which will be this 1-dimensional array here. So we run that and we get 18, 19, 20. And then finally, when we run this line here with the additional 1, we will get of this 1-dimensional array the second element, so the 19. Okay, so that's how we access a single element of a n-dimensional array. Now let's say we're interested in multiple elements. And multiple elements doesn't just mean we take, as we did here, this whole block, because in a sense that is just one element, but maybe we could be interested in the first 2 elements of the array here. And so to get these 2 elements, we again write our array and then these square brackets, but this time we're putting the index, or actually the 2 indices, also into square brackets. So we're writing square brackets and then 0, 1. And this then gives us the first 2 elements. Another way of accessing multiple elements is slicing. And the syntax we need for slicing is defined by a start, stop, and step argument. So again, we write our array in the square brackets. And then let's say we want to start at index 5, which will also correspond to the 5th element here. And we want to go until the index 20. So if we run that, then we start at 5, but we see the 20 is not included. So this tells us that the stop argument is exclusive. So if we also want 20, we write 21. And then behind the stop argument, we can also put the step size, or also called the stride. So let's say we want to take every second element. Then we put the colon and then a 2. We run that and now we skip the 6 and jump to the 7. We skip the 8, we go to 9 and so on. Down here we have another example where we take half of the array, so we go from 0 to 50 and we select every 5th element. And of course this also works for multidimensional arrays. So in here we create an array with 100 elements and we reshape it into a 10 by 10 array. Let's put that in an additional cell and also display it. And now from the first dimension, which concerns these elements here, 1, 2, and so on, we go from the beginning 0 up until 8 and we take every second element. Let's write that out here. So 0 to 8 in every second element. And now when we slice across the second dimension, there's something we have to look out for. because in the beginning we said we can either separate our syntax by a comma or put it in separate square brackets. But because the slicing here does not select a specific dimension, but just slices the array, our second set of square brackets will not operate on another dimension, but just on a subpart of the original array. So in this case, it's important that we use the comma syntax. So let's actually see how it looks without. So if we put it in separate square brackets, the 0 until 10 with a step size of 5. So we start at element 0 and we go until element 10, which doesn't actually exist here, but it will still work. And we do with a step size of 5. So we take the first element and then every fifth element, but we only have 4 here. So the only element left will be this here. And we run it and we see only that is left. And this is of course not what we want. So actually we want of the second dimension every fifth element. So that means the 0 and the 5, the 20 and 25 and so on. So if you run this cell down here with the proper syntax, where the slicing is separated by a comma, then we get these values. Next up are negative indices. And negative indices will start from the back of the array and count backwards. So here we have an array with 10 elements, and if we put -1, we will actually get the last element. So you can also imagine we start here at 0, and then -1 goes to here, but because there are no elements here, we jump again to the back, and then count in the backwards direction. So this gives us 9, -2 will give us 8, and then so on. And this of course also works with slicing. And the cool thing is we can also put these negative values into our step size. So instead of going 0, 1, 2, 3, this will start at the back and give us then 9, 8, 7, essentially reversing the array. And you might wonder about this colon here, but this just means we take the default values for start and stop, which are beginning and end of the array. So this would be the same as putting 0 and 10 in here. So we run that and we see our array got reversed. Okay, next step is masking and filtering. And we can, for the most part, use these terms synonymously, but there are also filtering methods that don't rely on masking. And you can check that out here if you're interested. And so how masking works is that we take our original array, which is here again an array with 10 elements, and we apply some condition to this array. So in here we apply modulo 2 and check if that's equal to 0. So in other words, we check if the array is divisible by 2. And if we run that, this gives us then a Boolean array, or also called a Boolean mask. And this mask tells us at which indices the given condition is true or false. And so with this Boolean mask, we can filter arrays based on the respective condition. And this is simply done by writing our array and then putting the mask into the squared brackets. And this will then return us only the elements where the mask evaluates to true. So we run that and we only get the elements that are divisible by 2.